Algebra 1, Lesson 19. Exponents, powers of negative numbers, roots, evaluation of powers. Alright. We're going to focus on the exponents, the roots, and then the evaluation of powers. So in our practice, they've got a lot of problems. We're just going to do C, D, E, and G. So, starting with C, evaluation of powers. So we've got different types of exponents and negatives. Now remember, if the exponent, if the negative is not being included with the whole number with a set of parentheses, then the exponent is applied first, and then the negative is applied like a multiplication. So we'd still be following our rules of PEMDAS, or orders of operation. So we start with the exponent first. So negative 3 cubed, the exponent 3 times 3 times 3 gives us 27, and then we multiply that 27 times the negative. So this becomes negative 27. Now, in this one, since the negative is included in a set of parentheses, this exponent is being applied to the 2 and the negative. So we can read this one as negative 2 times negative 2. Negative 2 times negative 2 is a positive 4. So this becomes positive 4. Then we apply the negative outside the parentheses, which makes it minus 4. And then the last one, the negative is not included in parentheses, so this just becomes 4 times the negative, which also becomes another negative 4. So then we have negative 27 plus negative 4 plus negative 4. Negative 27 plus negative 4 gives us negative 31. Negative 31 plus another negative 4 gives us negative 35. And that's our final answer. Now D, roots. So there's two ways we can do this. We can memorize our cubed roots and memorize our square roots, or we can use a factoring method. So I prefer the factoring method because it's a little more logic based. But let's get on with the factoring method. So for the factoring method, we've got negative 64. So we're going to factor what times what could equal negative 64. Well, we could divide it by 2. All right, that gives us 32 and 2. We can divide 32 by 2, and that would give us 16. 16 we can break into 4 and 4. So now we've got two pairs, but this is a cubed root, so we're not looking for pairs, we're looking for threes. We need triplets. So we can factor each of these 4s into 2 and 2. So then we've got 1, 2, 3, that's one pair, and then 1, 2, 3, which is one pair that satisfies this root number. So this would then become 2 times 2, which gives us 4. Now, the other thing you have to remember is, since this is a negative and this is a cubed root, we can have a cubed root of our negative number, but our root is also going to be a negative number. So the cubed root of negative 64 is negative 4. If we take negative 4 times negative 4 times negative 4, we get 64. That's our answer. So an easy way to remember that is with cubed roots, factor looking for groups of 3. Once you find your groups, make your answer a negative always. Let's go on to E. So we'll draw a line kind of dividing this problem. So we have negative 3 cubed plus the cube root of negative 27. So let's start with negative 3 cubed. The negative is included in the parentheses, so negative 3 times negative 3 gives us positive 9. Positive 9 times negative 3 gives us negative 27. And then we have to add the cubed root of negative 27. Well, if you realize what we just did here, the cubed root of negative 27 is going to be negative 3. But in case you didn't, you can go ahead and factor it. 3 times 9 would give us 27. 3 times 3 gives us 9. We have one group of 3, which satisfies the radical, or the root. So we take 3, and since this is a negative cubed root, we're going to make it a negative 3. So then we have negative 27 plus negative 3. And that gives us negative 30. The very last one, we're doing evaluations with exponents. So this is the exact same thing. To show you what it looks like on the paper, this is problem G. It tells us to evaluate this expression if x equals these values, but we add exponents into the mix. So to solve this, we're going to do the same thing we did on the last ones. We're just going to use the plug-in method or the substitution method. And every time we substitute anything, we do it inside of parentheses. So instead of writing x here, I'm going to write parentheses negative 3. And then I put the exponent. Now you'll notice that this exponent has that negative being included. This is the correct way to write it. And that's why we always substitute inside of parentheses. Instead of writing x, I just put the parenthesis value, and then I put the exponent right where it would be on the x. And then from there, touching that, we have the z, which is -2. So we put a set of parentheses, -2, and then the exponent of z is +3. Then lastly, y is also -2. So now we just have to simplify this equation. We start with the exponents. -3 squared gives us +9. -2 cubed gives us -8, and these are all being multiplied. And then the last one is just -2. So we can multiply, okay, let's see here. 9 times -8 would give us -72. -72 times -2 is going to give us a positive number. 70 times 2 is 140. 2 times 2 is 4. So that's got to be positive 144. And that's our final answer.